Okay, good day everyone. Welcome to our second part of analytical geometry. So now we're going to look on what you call parallel lines, perpendicular lines, collinear points, and equation of a line. Okay, so that's what we're going to cover now. Okay, so let's get to see what you need to understand. So you just need to know the properties of properties of your parallel lines, properties of perpendicular lines, properties of collinear collinear points. Okay, all right. So here is what we have here. So when I talk of parallel lines, this is a sign for parallel lines. Okay, so whenever you see an arrow that goes the same direction like that, so and arrows like this, so you know that those two lines will be, that's indicated, will be parallel to each other. What do you mean when you say parallel lines? Parallel lines, lines that never meet. They never meet. They never meet. So parallel lines, they never meet. Okay, so I'm very sorry for my apology. Now, so lines that never meet are parallel lines. Okay, so when I talk of parallel lines, remember we are going to use a gradient. Remember, we're going to use gradient to relate these lines in analytical geometry. We're going to use a gradient, and your gradient, you know that is m. Okay, it's what? It's m. So we're going to know that MAB is equal to MCD. So whenever lines that are parallel, it means that M1 is equals to M2. So for lines that are parallel, the gradients are equal. Gradients are equal. Gradients are equal. So you know that once you just need to find the gradient of one of the line, then you know that the other line already you have it because they should be equal. Okay. So if you are going to maybe use a gradient for CD to do other things like calculating an equation of a line, determining equation of a line, but you can only find equation or sorry, gradient of AB. Yes, you calculate gradient of AB, then you know that the gradient of AB is equal to the gradient of what? Of CD. This is the trick that you need to understand. Okay, so now let's move on to perpendicular lines. Perpendicular lines, you must know that perpendicular, they meet at 90 degrees. They meet at what? 90 degrees. So this is a sign that you will see that this is a sign for perpendicular lines. Okay, just like that. So perpendicular lines, you can see here what we have here. So they form 90 degrees, and what we have here is MAB times MCD give us -1. So you must know that whenever you are given perpendicular lines, you know that by finding gradient of one of the line, you can automatically calculate the other one. Okay, so you don't need to calculate both of them. You just need to calculate one, then the other one you can determine using the equation that you know already. So M1 times M2 give us -1. So let's have an example here. Let's say MAB is equal to 2. Now we want to calculate calculate MCD, gradient of CD. But we know the property MAB, since they are perpendicular, calculate AB if MAB is perpendicular, if AB is perpendicular to CD. This is the property that you're given. You know that MAB times MCD give us -1. What is that? You substitute here, it's going to be 2. MCD is equals to -1. Then MCD is equals to -1 over 2 because they divided by 2 on both sides. So that's your value here of gradient of MCD. That's how you calculate gradient of MCD. Okay. So given 1, you just need to substitute for it, equating to -1. Then you solve whatever you have. So imagine if you are given -1/4 or -1, or negative MAB is equal to -1 over 4. Okay, now we want to know that, all right, what is it that we can find? Calculate CD, calculate MCD if AB is perpendicular to CD. All right, what do we do here? We know that MAB, you must always write these formulas, please. Okay, these general formulas, you must indicate this one first. Okay, these are just formulas that you need to just indicate. Or M1 times M2 give us -1. Now what do? We say negative 1 over 4 mcd is equals to negative 1. Then if we divide both sides by negative 1/4, you know that you're going to get what? You're going to get 1 here. And if we say negative 1 divided by, what do we have here? We're going to say negative 1 over 4. Okay. You see what we get? We get a 4. So that's a 4 that we get there. So your answer there, MCG, will be therefore equal to 4. That's how you get. That's how you calculate it. Okay, that's what you must understand there. Then when I'm talking of collinear lines, collinear points, or collinear points. Okay, collinear points are points in a what? Straight line. Points in a straight line. Okay. Apology for my interrupting. Now we are saying what you call A, B, C are in a straight line. So what do we have to deduce about this? We know that, all right, we must know that MAB is equal to MBC is equal to MAC. So gradient is equal throughout. So gradient is equal on points. Okay, so or throughout the line. Okay, that's what you must understand this. So gradient is actually equal throughout the line. Okay, so we must know that the gradient for here, for these 2 points, between these 2 points, is equal to gradient between these 2 points is equal to gradient between these 2 points. So it's one gradient that you must have. So you mustn't struggle with this. If we are to be given gradient, let's say it's gradient MAB that is given, AB that is given, but you want to calculate maybe it's 2, then it means that gradient of also BC will also be equal to 2, gradient of MAC will also be equal to 2. That's what you must understand that. So whatever you need to calculate it here, if you need the gradient for this point, but you're given 2 coordinates for this, you calculate the gradient using the formula that we did together on the first chapter, okay, on the Analytical Geometry 1. You use that same gradient, okay, to use here, okay. You use it on BC because you know that the gradient are gradients are equal. So let's now look into equation of a line. So equation of a line is in the form of y equal to mx plus c. Y is equals to mx plus c. So m is your gradient, okay, and your c is your y-intercept. Y-intercept, this is where your graph touches the y-axis. So where the graph touches the y-axis, that's what you call a y-intercept. Let's have an example here. Let's calculate the gradient, the equation of a line. Let's have an example here. Equation of a line. So let's check here what we have here. We have the gradient here that was given these lines here, and we need to calculate the equation of a line. So what we must know that we must first of all, you need your gradient. First of all, you need your gradient, and you need to substitute into this equation. Let's have the easiest method here. You know that the y, you say y minus y1 is equal to m x minus x1. That's what we have. So this, once you calculate the gradient, you have to use one of the coordinates between those 2 points that you are given. You use two coordinates to calculate gradient. So m, you use 2 coordinates. Calculate gradient, okay? Now, when you're substituting in this equation now, you only use 1 coordinate. That's what you need. You need 1 coordinate now to substitute in the original so that you can come up with an equation. Let's give an example. Let's calculate CD. Okay, so we know that equation of CD, equation of CD. So let's say CD first. Okay, so we're going to say MCD is equals to change in Y. Okay, YB minus YA over XB minus XA. Remember to write the formula. What do we have here? 3 minus 2. 3 minus 2, then 5 minus 3. 5 minus 3 in terms of x. Then what we have, 3 minus 2, we get 1. 5 minus 3, you get 2. So your gradient is equals to 1 over 2. Okay. Now, what do we need to do now? We choose n of these points. So let's just use C. 3 and 2. So we're going to say, all right, our general equation here is going to y minus y1 is equals to m x minus x1. Okay. Now what do? We use C. So y minus, we take the value of C minus 2 is equals to m is 1 over 2. Okay. In bracket x minus, what is the value of x is 3. Okay. That's what we have there. Then what do we do now? We need to clear the equation here. We're going to say y minus 2 is equals to 1 over 2x. We clear, we remove the bracket. Half minus x, we get x, half x, half minus this, you minus 3, going to give us negative 3 over 2. That's what we have there. Okay. Then now what do we do now? We take to that side, y is equals to 1 over 2x plus minus 3 over 2 plus 2. Then what do we do now? We calculate that. So we're going to say minus 3 over 2 plus 2. What do we get? We get half. So we're going to say y is equals to half x plus half. Okay. Then that's our equation there. That's our equation there. So our equation here, remember, it must be in the form of y is equals to mx plus c. So our m in this case is half. Okay, our C, so this is our C. So this is our M. So our M is 1/2. You don't need to do this. I'm just showing you. C is equals to half. You don't need to write this. This is not necessary. I'm just trying to show you what we mean by this. So it means that your graph here, it will pass what call if it is if we are to draw it continuously here. What we have here is going to be, it's what y c is equals to half. So it means that the graph must, it's just that we didn't draw this to scale, but it means that it must pass through here, this point here. It must pass here. Okay. So but we didn't draw our graph to scale, our graph to scale here. So it means that we're going to say maybe it's gonna be like that. It's no longer a straight line though, but I'm just trying to show you which there is no bend here, but we didn't draw it to scale here. So it means that, but it must pass through half. That's what you must know then. Okay. Now, that's it. So here you can use any of the points. You can choose this point. You can choose this point. So let's just try to see, just to cross check here. If we are to use D, if we are to use D, so let's use D as what? D is 5 and 3. I just want to show you here what that you can understand. Y minus y1 is equals to m x minus x1. Okay. What do we have here? Y minus 3 is equals to m is what? Half. X minus x1 is 5. Okay. Then what do? We say y minus 3 is equals to half x minus 5 over 2. Okay. Then y is equals to half over 2x. Then if we are to check here, minus 5 over 2 plus 3, then what do we get? Half, sorry. What do we get here? Half x minus, we don't know the sign here. Let's just try to check here. Y. So we're going to say minus 5 over 2 plus 3. What do we get? We get half. Okay, so this is what you have here. So you can see that you can compare your answers here. This is the same answer that you are getting there. That you must understand. So you just need to calculate gradient first. Then after calculate the gradient, you use n of the point that you have. You just need a gradient and 1 point. So imagine if in the case that you are given a gradient already and you're given 1 point, you don't need to stress about doing anything. Just come straight to this part here and say y minus y1 is equal to m times x minus x1. Then your what you call your x and this y are the ones that you find on the what you call on your original equation. Okay. So here, as you can see, that your graph is going up, it's an uphill, and our gradient is also what? Positive. Okay, gradient is also positive. So let's check here with the negative one. Okay, just a quick check. Just a quick check here. Let's see here what we have here. We're going to say, all right, m. What is m here? M pt is equals to yb minus ya. Okay, over xb minus xa. Okay, what do we get here? We're going to say, what is the x value here? What is the x value here? Sorry, the y value. Here we're going to say minus, it's minus 4. Okay, minus 4 minus 3 over 4 minus 1. Okay, then what do we get there? Minus 4 minus 3 is minus 7, minus 4 minus 3 is minus 7 over 4 minus 1 is 3. So what we get here is minus 7 over 3. That's your gradient here. And we come here and say, let's choose n of the points. We can choose n of the point there. Which point do you want to choose now? So let's choose t. And t is what? It's 4 and negative 4. Then what do? We say y minus y1 is equals to m x minus x1. Then what do we have here? Y minus y1. What is y1 here? It's 4. So negative 4 is equals to what is m? Negative 7 over 3 x minus what is x1 minus 4, like that. Then what we have here? Y is going to be y plus, because y minus minus plus 4 is equals to negative 7 over 3 x plus 7 over 3, negative 7 over 3, negative 7 over 3 times negative 4. What do we get? We get 28 over 3. Then 28 over 3, as you can see here, we take 20 over 3 minus 4, because we're going to say y is equals to negative 7 over 3 x plus 28 over 3 minus 4. Then we're going to say minus 4. What do we get? We get y is equals to negative 7 over 3x plus 16 over 3. That's what you should there. Okay, that's your equation of your line. So you must not check there that your gradient here, your gradient is what? Your gradient is negative, but your y-intercept here, your y-intercept is positive. As you can see this graph here, it will pass through, it will actually cut the y-axis on the positive side. Remember we said positive side, so to cut the y-axis on the positive side, that's the y-intercept. Okay. All right. Now I think we did this question on our previous lecture. Okay. So here the question: consider the following points on a Cartesian plane: A 1 2, B 3 1, C negative 3, K, D 2 and negative 3. Determine the values of K if. We're going to do this part here because we did the first part, okay? The midpoint. You must check on the first lesson. If AB is parallel to CD, so we are told that AB is parallel to CD. What does that mean? It means that MAB is equal to MCD. Okay, so what must we do now? We must first calculate the gradient of AB. Gradient of AB, MAB is equals to Y, change in YB, YA, sorry, over XB minus XA, which is equal to what? which is equal to AB, we're going to say it's going to be 1 minus 2 over, we're going to have what? 3 minus 2, 3 minus 2. What do we get? We get 1 minus 2 is negative 1. So as you can see here, what we have here, 3 minus 2 is also is 1. So 1 minus 2 is negative 1 over 1, which is equals negative 1. So the gradient there is negative 1. Therefore, MCD is equals to also negative what? Negative 1. But how would we calculate the gradient of CD? We're going to say, all right, it's not a big problem here. Change in Y over change in X. We're going to say it's going to be the D points is negative 3 minus K over 2 minus 3 for the C. So we're going to take this negative 3, we subtract the K, we take the 2, we subtract the 3, was minus and minus. Then what do we get here? We're going to get negative 3. So this is equal to negative 1. Sorry, this is equal to negative 1. We are forming an equation now. We need to find K now. So what do we have here? Negative 3 minus K over 2 minus minus give us 2 plus 5 plus 3, which will give us 5 equals to negative 1. Then negative 3, negative K is equals to, we multiply by 5 throughout. So we cancel the 5 here. Then 5, negative 5 times 1, it's 5 times negative 1 times 5, we get negative 5, okay? Then we say negative 3K is equals to, we take this K, 3, going to be positive, that side is going to be negative 5 plus 3, which is equals to negative 2. So this is negative K. So what are we going to get here? We're going to say by negative 1, K is going to be equal to 2. That's how we get the K there. That's your value. That's your value of K. If you are given that, those two are parallel. All right. Now let's see here. We're also told that what if AB is perpendicular? What if AB is perpendicular now? What do we know about AB being perpendicular to CD? We know that very well. MAB times MCD must give us negative what? Negative 1. We already got MAB, which is negative 1. So what are we going to do? We know that MAB is equals to negative 1. We have calculated it. So here we're going to say, therefore, negative 1 here times what? Negative 1 times MCD is equals to negative what? Negative 1. Then we divide by negative 1 here, divide by negative 1. MCD is equals to 1. Because if we say negative 1 divided by negative 1, you get 1. So gradient of what is it? Of MCD is equal to 1. That's what we have here. Then we come again to the format for equation for the gradient to find CD. We're going to say again negative 3, okay, minus K over 2 minus 3 must give us in this time 1. So if we are to equate to 1, what must we get as K? Then we get 5 here, like what we did here, is equals to 1. Then we have put 5 here. 5 that side, it multiplies, get negative 3 minus K is equals to 5. Then we take 3 that side, negative K is equals to 5 plus 3 is 8. Then if we divide by negative 1, divided by negative 1, K, you get what you call 8, negative 8. Okay, that's your value of what? That's your value of 8 of K. So K in this case is equal to negative 8 if they are perpendicular. Now we want to know that if your lines are collinear, if A, B, C are collinear, meaning A, B, and C, A, B, and C are collinear. What does that mean? It means that A, gradient of AB is equal to gradient of BC is equal to gradient of what? AC. Okay, so in this case here, we're going to use gradient of what called gradient of AB. Gradient of AB, MAB is equal to what? Is equal to negative 1. And therefore, you're also here we're just supposed to say equal to negative 1 here. So that we know that M what here? MBC is equal to also what? Also -1. So if MABC is equal to -1, we're going to use which coordinates now? We're going to use these coordinates here for B and for C. And for C, we know that is -3 and K. And for B, we know that is 3 and 1. So we're going to say, all right, what is MBC? MBC is equal to YB minus YA over XB minus XA. You must practice this. You must practice writing this, sorry. You must practice writing this so that you get used to it and you get to understand it better. Okay. Now here, what are you going to get here? We know that we're going to say we take K minus 1 over -3 minus 3. We get what? We get -1. Then here we get -6, -3 plus -3, we get -6. It's going to be K minus 1 is equal to over -6 is equal to what? -1. Then you multiply both sides by -6. K minus 1 is equals to -1 times -6. Then -1 times -6, what do you get there? What do you get there? We get negative. We get positive, isn't it? -1 times -6, you get a +6. So K minus 1 is equals to 6. Then K is equals to 6 minus 1 is equals to 5. So in this case, K equal to 5. That's how you're supposed to calculate your what you call your values of K. Because here, remember, you are using the properties that you know that perpendicular lines. If I multiply the gradients, I get -1. So that's how you can calculate the gradient of vertical of the missing points. Now here, if you know that your point is stated that the coordinates are collinear, you know that the gradient is the same throughout the line. Okay, that's what we have there. Then okay, so let's look at the second question again. A 1 and 4, B -2 and 2, C 4 and 1, M X and Y. Now are points on the Cartesian plane. Use analytical methods to determine the coordinates of M so that A, B, C, M is what in this order is a parallelogram. Now we know that a parallelogram, let's just have a sketch of a parallelogram here. Okay, parallelogram must have two sides must be parallel, two sides must be also parallel. Okay, pair of opposite sides must be parallel, and you must always remember that the diagonals bisect. So in other words, here this line here will be equal to this line, will also be equal to this, it will also be equal to this. Okay, and here the gradient here, these sides are also opposite and what and equal. You must understand that they're opposite and equal. The sides are opposite and what and equal. These signs are a sign. It shows that lines are equal. Okay, so that's what we have there. So you must know that right in this case here, the lines for parallelogram, opposite sides are parallel and equal. Okay, then diagonals bisect at what you call bisect. Sorry, bisect. When you say bisect, they divide into two equal parts. Okay, so understand this. Understand something here. Let's have A, B. We're just gonna draw here. Okay, we're not going to plot what we have here. We're going to say, all right, A, B, or maybe let me plot it nicely here. A moment. All right. Now here, I've drawn a Cartesian plane here, but what I know here is that if we are told that A, B, C, M is a parallelogram, we are going to label here A, B, C, M. So we would assume that M is that side, okay, on that side. So on our Cartesian there, we would assume that M is somewhere here. Okay. Now what are we going to do now? We know that right. This are diagonals. These are diagonals here. So diagonals here, the two diagonals that we have here, two diagonals, are what? Are AC and what? And BM. So these are two diagonals. And you know that the coordinates, since these two are bisecting, it means that they do have the same coordinates. And in this case here, this becomes midpoint for all of them. So whenever you're given a parallelogram, okay, and they want you to calculate the coordinates of any other thing, you know that, right? In a parallelogram, the two here the diagonals bisect, mean that at the center is the center for all these, for two diagonals. Okay, so it means that they have one center. They do have what? One center. They share one center. So we can calculate this quickly. We can say, all right, since we have AC as the what, as the gradient, okay, we have the coordinates for A and C. We do have coordinates for A and C, okay, but we don't have gradient for M. So we're going to say, all right, A and C, we're told that A and C, let's just do this, okay, here's what we have. Okay, we're going to say, all right, A and C is, we're going to say midpoint of AC is equal to, remember, xb plus xa, okay, sorry, over 2 yb plus ya over 2. That's what we know. Now, what we do now, we're going to say, in terms of x, we're going to say 1 plus 4, 1 plus 4 over 2, okay? Then in terms of y, it's equals to 4 plus 1 over 2, okay? What do we get there? We get 5 over 2, then you also get 5 over 2. That's what we have here. So we know this is a midpoint, okay? And what do we know about midpoint? We know that, all right, if we are going to say the gradient for MC, let's just squeeze here. Oh, we're going to need it. So here, if we're going to know that MAC is equals to MBM, we're going to say, all right, for MBM is equal to what? Is equal to, what we have as B is negative 2 plus X. X for what? XM. Remember, X for M. Now, here over 2, then 2, sorry, in terms of Y is 2 here, plus YM over 2. Then this is equal to what? This one, this give us what? This give us negative 5 over 2 over 5 over 2. So this is equal to 5 over 2, 5 over 2. So we're going to divide these two equations and equate them, okay? Find the value of x here. So for x, we're going to say negative 2 plus xm over 2 is equals to 5 over 2, okay? Then you multiply by 2, both sides, remember, to remove the denominator. Negative 2 plus xm is equal to, we cancel this, is going to be equal to 5. Then x is equals to 5. Remember, 2, if 2 goes that side, is going to be plus. It's going to be 5 plus 2, which is equals to 7. So we know the value of x now. Then the value of y, we're going to say 2 plus ym is equal to, over 2 is equals to 5 over 2. We do the same, multiply by 2, multiply by 2. It's going to be 2 plus ym is equals to, what do we have here? We're going to get 5 here. So ym is equals to 5 minus 2 equals to 3. What do we have now? We have with the points of m now. M is going to be equal to 7 and 3. Are these 7 and what? And 3. That's what we have. And even if you check here, it's going to give us 7 in terms of x and 3. So it's gonna be between and in terms of a, the area is gonna be below here. It's gonna be somewhere here. M is gonna be somewhere here. So M is gonna be equals to, which is gonna be 7 and 3. Okay. Then if we are to check here, Remember the reason why you get funny diagram here is because we are not drawing here. We are not, our drawings are not to scale, but you can get a clue here of what are we doing here. So this line is parallel to that, and this line is parallel to that. That's what we have there. Okay. So here it shows that, all right, as you can see here, in terms of what we call x is from -2, okay, -2 to 4. We expect the same here. If we say -2 to 4, we want to calculate the distance there, change in x so that you can see that are they parallel, is the distance the same. So you can see that it's gonna be what is it? 4 minus 2. What do we get? We get 6. Then if we are to check here in terms of x here for these two a and m, if we say 7 minus 1, you also get a 6. So you mean that you move same units, 6 units, and you also move 6 units in terms of x. Then in terms of y, remember you can have 4 here, 4 here, we have got 4, 3 here. So it's just 1 unit downward. Then here again, we have got 2 here, and we have got 1 here, so it's just one unit downward. Okay, so it means that this is actually a perfect parallelogram. Okay, so that's what we have there. Okay, so this is the tricky part of the questions, and I hope we are done with we are done with our chapter, not our chapter necessarily, but our part 2. We're going now to look on the next lesson. On the next lesson here, we're going to look at we're going to look on what is it? We're going to look on the circles. We're going to look on circles and circles with the tangents. That's what we're going also to look at. So thank you so much. Until next time. So you can also write your questions under this, under the lesson where we're going to upload them. You can also put your questions, the way that we have it, we attend them. Okay. Thank you so much.